All right, so we are going to do 3-3 day one today, and this is a very important lesson because this totally builds tomorrow. So make sure that you put your best foot forward as we learn about this process. Okay. So what I would like for you to do is look at 1, 2, 3, and 4, and you're going to describe in words how to make figure A turn into figure B. So in other words, what can you do to figure A to make it look there? Okay, so you're going to write a description and then we're going to talk about it. Okay, so go ahead and do that first. So with number 1, hopefully we did something along the lines of it's getting stretched of some sort, right? We are stretching it. Technically, we're stretching it vertically. Maybe you said it doubled in size, right? But obviously it's the same picture, we just made it larger, right? It didn't get any fatter, so it's nothing horizontal, but it just stretched up, right? For number 2, hopefully we noticed that it just kind of increased, right? So it moved up. Maybe you got specific and said that it moved up. How many did it move? If that's at 2 for our y, and if we go all the way up here, it's at 1, 2, 3, 4, 5, 6, 7. So go from 2 to 7 means it moved up 5. Okay, so moved up was fine, but moved up 5 is the most correct. And then we get number 3, and there might have been a lot of words used here. Most often you probably said flipped, right? Flipped upside down, whatever. Technically, I want you to think about it more as a reflection, right? Because flip, I mean, who knows? Maybe that would have been this way, right? And you would have had your guy. Wow, this is a great picture. But you would have had him here, okay? And that's the vertical flip this way, or sorry, horizontal flip that way. But I want you to think about it more as a reflection. So we're reflecting off this line here, is all it did. Okay. And then on the last one, this one should have been another easier one. You definitely moved left this time, right? It moved to the left, and specifically it moved left. So I'm going to focus on this one, right? If I move that to this spot, that means it would be on the y-axis. So that moved over 1, 2, 3. Okay, now again, you could have just moved left. You didn't have to say 3. Okay, but this is a big foundation of what we're doing today, and we're going to start turning it into functions and putting it in function notation as well. But we're going to base it off of graphs too. Okay. So at this point, I would like for you to follow whatever it says in your OneNote. So you're going to have to go to your page, and there will be a link for your class here, okay? And you're going to pull up this Desmos activity, and you're going to follow the instructions for it. It's very, very important that you try these out and you try to make some sense of it before you come back, okay? Once you get to slide 6, you're going to record your answers here. So slide 6 is literally going to look like this. Okay. So once you get there, you're going to record them here versus on Desmos. Okay. And we're going to go over them here as well. Okay. So go ahead and do that first before you listen to what I have to say. So on slide 6, hopefully we're starting to get a grasp of what this looks like in function notation, right? For letter A, okay, that would be the red one right here, right? In order to get that to look like f of x, okay, we had to go down 1, 2, 3, 4, 5, all right, and left 1, 2, 3, okay? So essentially you're thinking down 5, left 3, okay? Now, notice how I just picked the bottom left point of f of x, and I just moved that one, okay? That's how you can do it for all of these. You could have also picked this point on f of x or this point on f of x. It doesn't matter, okay? You just move one of them. So we should have ended up with f of x, and it would have been plus 3 and then minus 5. Okay, so notice how it's left 3, but it says plus 3. If we look at B, same deal. I'm going to start with this bottom corner, and I have to move up 1, 2, 3. So I know it's going up 3. And it moved right 2. So hopefully we got to the point where we saw that it would be f of x minus 2 and then plus 3. Okay, so again, right 2 gave us a minus 2 on the inside. Hopefully this one didn't stump us too much. There's something wrong with C. And if you start counting, this top one is through 4 spaces where it normally is through 3. So you cannot do this one. Okay, there's no way for us to do that actually. That one was a little tricky. And then we have letter D. Okay, again, I'm going to focus on this bottom corner. So I'm going to move right 1, 2, 3. And then I move down 1, 2, 3. So right 3, down 3. So if I'm moving right 3, it would be x minus 3. And down 3 is also minus 3. So hopefully we're starting to see the pattern of the fact that when it's inside or left and right, it's going to be the opposite of what you normally would see. It's kind of like point slope form. Okay. Our last one is E, which if we start from this bottom left, all we do is move up 1, 2, 3, 4, 5, 6. So it's just f of x and then plus 6. Okay. No left and right. That means nothing on the inside. All right, so this is definitely the foundation of what we're doing today, but this is all coming from this function notation. So y equals a f of x plus h plus k, all right? Now, a actually does a lot, and it's a number out in front. We haven't really talked about it all that much up here, okay? But it is a super important one, okay? And what it comes down to is when a is greater than 1, aka a whole number, basically, what happens is it's going to be a vertical stretch. So this is what you're thinking about with the giraffe, right, above. So with the giraffe, right, it vertically stretched. That was an A situation, okay? When A is between 0 and 1, aka a fraction, right, it's going to be vertically condensed. So this is kind of like a shrink. Okay, it's going to go from this big to then be this big. Okay, so it's just a vertical condense. The only other thing that happens is if it's negative, then this is where it reflects over the x-axis, and we'll talk more about that in a little. Our h value, if you notice, is the one that's inside with x. Okay, hopefully, if you think about what we did up here, anything that was on the inside with x was actually moving it left or right. Okay, it moves left when it says plus h, and it moves right when it says minus h. Okay, so in other words, it's the opposite sign, and it's kind of like what we talked about with point slope form, right? Anything with point slope form inside those parentheses, we always took the opposite value. Haha, see, I told you we would have to do that at some point, right? So you're always taking the opposite when it's inside the parentheses. Now, if you notice with your k value, which is the number on the outside, that was always exactly what it said. Down 5, it was a minus. Up 5 is a plus, right? So down would be a minus k, up would be a plus k. So it's always the same, okay? So we're going to practice using these things, and feel free to use this as a reference if you wanted to jot it down on a piece of paper first. Or have this on the screen as well while we're doing these next ones. So I want you to try to do this on your own before you listen to me explain it. And you're just trying to tell me what it's doing. So is it moving left? Is it moving right? Is it up, down, condensed, stretched, flipped? Okay, reflected, sorry. And see what you can come up with. For number 4, I'm just going to start with the first number that we have, and we have this -2. So that's your H, okay? And then we also have a K over here. So I know H means left and right, K means up and down. So with H being a -2, really it's a +2, okay? Remember, it's always the opposite sign is what you're thinking. So that means it's moving right 2. Now my K is 3, and K values are just exactly what it's supposed to be. So if it's 3, that means we're moving up 3. So inside moves left and right, outside moves up and down. On this one, we have a 2 to start. Whenever it's a number out in front of the f of x, that means that it is your a value. So this is my a, which means this is going to be vertically stretched because it's a number that's not a fraction between 0 and 1. It means that it's going to be stretched. And then we have this -1 outside, meaning this is your k value. And remember, k's are exactly what it means. So this would be down 1. Technically, we should have a vertical stretch of 2. And our last one, okay, again, we have an a value, but this time the a is negative. So the fact that it's negative, it means that it is reflected over the x-axis. And then it being 1/2 means this is a vertical compression or condensed. Either way, compressed, condensed, same thing. And then we have this +5 on the inside. Remember, that means it's your H, which is opposite. So this means it would go left 5 because it's actually a -5. Now, this doesn't have to seem like the easiest thing in the world right now, but we are going to keep working with it for the next couple days. And it is a very important topic.